Good afternoon, everyone. Today we're going to continue our discussion on machine learning. Last time, what we did was to have a discussion of machine learning for classification purposes. This time, we're going to do it for regression. The main difference between those two methods is that for classification, your target variable, what you're trying to describe or model, is a categorical variable, in particular a factor. So you have different levels there. So for example, in our case, we were using the cardio data set where we have three levels N, S, P. So we would like to use the data, predict it, whether it's an N, S, and a P. And later on, use that model in order to predict a data that it has not yet seen. So that's why we had your training and your testing data sets. Okay, for today, we're going to start our discussion on machine learning, but this time for regression purposes. And the difference, as I said, for classification, your target variable is a factor. On the other hand, for regression, it's a quantitative or numerical variable. So the method will be quite different. You can't create a confusion matrix for a quantitative data. The confusion matrix was specifically for classification. For regression, we're going to use other metrics like Ramsey, which is root mean square error, MAE, MAPE, okay, MSE, etc. There are other metrics by which we can compare whether the model generated using a decision tree or a random forest or SVM or XGBoost or ANN or other methods class, which among them is the best for our specific data. And in the same manner, class, we're not going to use the whole data. What we're going to do is to split the data into two, into training and testing. Okay. And then later on, we're going to also learn how to split your data in case there are structural changes. For example, in most of the papers now, say you're one of the uh, groups that I'm advising is they're taking a look at the effect of cryptocurrency, Bitcoin, Ethereum, XRPass, and Tether on the foreign exchange rates. Okay. Now, for example, Ethereum or Bitcoin, Ethereum started was listed starting 2016 or 2017. So that's where we're starting with the data. Okay. XRPass, I think 2018. So the earliest should be 2018 or 2017, where the data are all available. Okay. We can't use a BTC or Bitcoin, which started in 2010. We can't use 2010 because the other cryptocurrencies don't have that data yet. So, uh, as I said, class, how do we now split our data? Okay, the simple one is to split it into, we're going to discuss this in a while. I'm just going ahead of myself. Into two, which the method that we're going to use is different from the one that we use for the cardio data set, which is a cross-sectional data. Because for a cross-sectional data, you can just get observations and group them randomly. For time series, you can't do that because there's a logical order. Okay, so it's either, for example, you start with the January 1, 2018 up to, let's say, December 31, 2020. That will be group one. That could be your training data set. And then the remaining will be your testing data set. So that's the difference, class, between uh, creating a training and a testing for a cross-sectional data and a time series data. So we'll see that in a while. So we're using the aapl data set. You know that this is if it's uh, using quant mode, in particular the get symbols from Yahoo Finance. This is an XTS object, so I will not show that anymore. An XTS object. Now, you know that an XTS object class, let me just show that. XTS object, I already have, I ran this already. The index class is the date class. And we learned before that this this can be accessed using the index function, and this also can be accessed using the core data. So what we're going to do is we're going to create another data, which is a data frame, because we might have problems using this XTS object for machine learning. So here, okay, if you take a look at this one, let's now create, I want you to run this class for some of the, okay, let me just, okay. So we're creating this object stock data, and we're creating a data frame out of that. Okay, so we're creating a column called date. Okay, and what will be the date? It will be the index of Apple. Okay, so we learned this before, that if we use index class, index of the object, it will get the index here, which are dates. And then core data of Apple will be this, the prices. So if you see this class, you have data frame. The first column is the date, getting it from the index of Apple, and the next is the core data of Apple. So these are 6 columns: open, high, low, close, adjusted, volume, and adjusted. Okay, and then let's so please run this class. I'll give you a few seconds. When you're done running it, please chat. Kindly chat in the chat box. Okay, thank you. Okay, thank you, Alice. Let's wait for the others. Alice, Katrina, Janine, thank you. Good. Therese, Ace. I appreciate class the speed by which the class responds. Okay, thank you. Thank you so much. Makes me really feel that you're there with me in this journey. Okay, so I hope the others are able to follow along. If you have any questions, please, you know the drill, raise your hand, ask questions. Okay, all right, so let me run this also. Okay, I have it already, so let me just uh, print it. Okay, stock data. Where's my stock data here? So I hope you also have 20, 25, 15 observations of 7 variables. The difference between the Apple data and the stock data is that you can now see that the index here, it does not have, the index is now simple numbers, one, okay, counting numbers. And then we now have here a column for the date. So this was extracted from the Apple index. And then the core data is here. So all the 6 columns. Okay. And if you get the structure, this is now a data frame. Okay, so why did we do this class? In order for us to be able to manipulate the data uh, and do machine learning with the data. It will be easier to do it with the data frame rather than an XTS object. Okay, so that's the rational class. Otherwise, why not just use Apple, the Apple dataset? Okay, so now if you want class, because sometimes you might wish to save your data, okay, you have stock data, you can save this. You can save it as a CSV file. So you can use write.csv or even write.xlsx. Okay, write.csv, and then what data are you saving? Stock underscore data. This is the data that we created, and then the file name that you want it saved. Okay, I just place here Apple stock data 2025 to 2024, and then .csv. This is very important because it's write.csv. If this was write.xlsx, then it should be .slsx. Then row names is equal to false because there are no row names. Okay, I think the default is row names is equal to true, so it will look for row names, but we don't have any row names class for our stock data. This is our stock data, by the way, here, right? There are no row names. So row names is equal to false. And then this will be saved. I will not run it anymore because I already have it here. Okay. So if you wish to save a data of your stock data, then you may run this. Okay. I'll give you a few more seconds for those of you who want to run that. Nothing wrong with saving a data, class, creating a data, creating a file, CSV file. It should be placed in your R project. Okay. Okay, now, as I said, class, we're going to do perform regression. What we're going to do is, by next meeting, we're going to model the log returns of our Apple stock data. So oftentimes, for time series, the lag value, okay, has a, shall we say, influence or relationship with the current value. So for example, the price today of a stock could have been affected by the price yesterday. Okay, so there's a relationship, there's an association between the price yesterday and the price of the asset today. Or maybe not just yesterday, but 2 days ago. So that's lag 2. If we're talking about daily data, okay, lag 1 is the price yesterday. Lag is equal to 2 is the price 2 days ago. If it's weekly data, then lag 1 will be the price the other week. Okay, so it depends on the context. Of course, if it's monthly, then it will be the price last month. Now, since we're dealing with daily data, kasi yung Apple natin, our Apple stock is daily data, then yung mga logs natin will be daily. Okay? So, we're going to make use of the past values as predictors. We're going to use them to explain, or they will be some of our independent variable for our dependent variable, which is the price, the current price. And we're also going to make use of other uh, technical indicators, class, in order to regress our the log returns of Apple. Okay, so these are commonly used like moving averages, RSI. Okay, may I ask you, class, did you encounter this term or MACD in your other subjects? Okay, let's say portfolio management or investment. I'm not sure. Okay, did you meet the terms RSI or MACD? So where in what subject, no? Ano to? What's in what's PM? In PM.
Investment portfolio management, sir.
Investment. Okay, thank
Sir
you.
Tianpao.
Okay, Sir Tyron. Okay, but did you plot it? Did you generate plots about that, or did you compute it?
We analyzed, sir po. Ganun.
Analyze, but you did not generate it, no?
Hindi po, sir.
Did you what software did you use in order to get MACD or RSI?
Sir Tianpao used examples po like in Instagram,
So you
sir.
were asked to open Instagram also.
Yes, sir.
Okay, good. So at least yon Instagram yon, no? Ito naman more on R tayo, no? So that this will add now more let's say more knowledge to uh give you more knowledge kasi R ang gagamit, we're going to use R. Okay. So first class, let's uh the more common ones that are used is are moving averages. So okay, let's first create, okay, ito muna tayo, no? Let's first create lag 1. Lag 1. Okay, lag 1 of our stock data. So, firstly, class, let's now create an object called stock data 1, which is your stock data. We'll preserve this yung stock data because we might need it later on, class. So we will not overwrite stock data. So let's create now stock data 1, okay, which is your stock data also. Okay, and then, okay, let me just get stock data. Okay, this is what we're going to do. Okay, we're going to create log 1, log 2. Okay, how do we do that? So I'm going to create here a column Apple, and then we're going to use the closing prices. No? Apple close log 1. Okay, so what does this mean, class? Log 1, class, means you're going to use as a predictor for today, for this date, January 5, we're going to use the previous value. lag 1 yesterday of January 5. So the yesterday of January 5 was January 2. 3 and 4 are Saturday and Sunday. So we're going to use the closed data set. So dapat class, this should be 27.3325. Okay. So the value class for this, I'll just use 27.33. Okay. And then this one will be NA. Why will this be NA? Because class, if you refer to the closing price, there's no prior value here. We don't have a December 30, 2020, 2014. So therefore, we can't put here a lag 1. Okay. I hope that's clear. For this day, we're going to use 26.5625, the previous value. So this will be 26.5625. Therefore, you have now a new column. You have now a new variable. Okay. And let's call it Apple close lag 1, which will refer to the prior value. Okay. So what will happen to the ending here? Let me close this. What will happen to the ending, to the most recent value? Let's go down here. Okay, the last row here, class, its value will be 255.59. Okay, so this one will go here, 255.59. So what will happen to this one, 252.2? Nothing. It will no longer be part of the column Apple close lag 1. Okay, why? Because we're not including here another row. Okay, we're not introducing another row here that will take up this value, 252.20. Okay, in other words, class, RB, everything, okay, everything class from the close, from 27.33.25, so which will go here, class, right, in this row, because this will be NA, class, NA, up to, so the first value here, up to the second to the last, here. So this will be removed from that row, class. Okay, may I have your comments, class, if you got the explanation? I just want to be sure that you understood my explanation. Okay, thank you. Janine, thank you. How about the others, please? Okay, good. All right, good. Thank you. That's why I enjoyed this class, because you respond really, and you respond very quickly. Thank you so much, really. Okay, so let's continue. Now, what will happen if it's log 2? If it's log 2 class, then the data here, the value here, let's say Apple close log 2. So it's another variable class. You have Apple close log 1, then another one, Apple close log 2. The last value here will be the 2 days ago, this one. It will be 259.02. It will now go here, class. So what will happen to these two latest values? It will be dropped out, class. So that's your log 2. For that matter, log 3, log 4, log 5, etc. So if it's log 4 class, okay, the 4 values here will drop out. Okay, and this one, the 5th one, will now go here if it's log 5. Okay, and then for log 2, what will happen? For log 2 class, there will be 2 NAs. Okay, I hope this is clear, class. No? So I'm talking about Apple close log 2. So here, it will be an NA. Why? Because if you take a look at the closing price here, and then if we take a look at 2 values before, 2 days ago, no 2 days ago, right? And then if you go here, it will also be an NA. Why will it be an NA? If we take a look at this, and then we get the price 2 days ago, so 1 day ago, 2 days ago, nothing plus nothing. So it will be NA also. Then on this row class, the value here will be 27.3325, this one. This one now will go here. Okay, y plus y. And this specific row, this specific date, two values before, 2 days ago, 1, 2, and 27.3325, then that will go here for your Apple close log 2. Okay, so let's generate now these two variables, Apple close log 1 and Apple close log 2, because we're going to use them as a predictor of our Apple close. Now, why that class? Because we said that there exist possibly temporal dependencies, which means that your value today could be dependent on the value yesterday, and that's a logical thing, especially in time series. Okay, so how do we now create this? Okay, that's very easy. Okay, let's go back to our model. I'll explain this class, no? Okay, so take a look at this. So I'm creating stock data 1, which is just the same as stock data. Okay, why is that so? I'm going to preserve stock data because we might need it later on. So stock data 1 $aapl close log 1. So which means that we're introducing now this variable class. To our stock data 1, I'm adding a variable called apple.close.log1. And what does it contain, class? It contains, see, you're combining the first one, the first row is an A, right? If you recall, class, if it's log 1, then the first observation will be an A. And then what will be next? We're going to get Apple close, okay? The whole of Apple close from stock data 1. We already have stock data 1 class here, right? And then -1, which means do not include the latest observation. Do not include the first one. That's -1 class. Remember, I told you, class, that the first value there will not be included in our log 1. And so, class, with log 2, take a look at log 2. Again, we're inserting another variable. We call it apple.close.log2. And it will be combining NA and then another NA class. So two NAs. And then, okay, we're going to use the head function. Head stock data 1 $apple.close -2, which means do not include the latest two observations. Okay, which is what we said a while ago. Okay, so I'm going to give you a minute, please. Generate stock data 1, and then see, class, if you now have two columns, if you now have apple.close.log1 and apple.close.log2, exactly as I described a while ago. Okay, please do that now. And then once you're done, kindly, again, please comment that you have created that variable. Oh, very fast. Thank you. Very good. Okay, wow. Thank you, class. Thank you. Really appreciate your cooperation. Okay, good. All right. Okay, I hope the others are able to follow. I'll give you a few more seconds. Okay, but you should be getting something like this. Okay, let me run this because stock data 1 is already, I was using this with another class, so you can see now that it's different now because we manipulated this already. So let me just close this and then create this one, another, I'll recreate stock data 1. And then there you have it, class. Okay, apple.close log 1, okay, 1 NA, apple.close log 2, I have 2 NAs, and then let's inspect the values here. Log 1, 255.59, so that will be the previous 255.59. And then this one, okay, so 259.02, because that's the prior 259.02 here. And you have these two values that are missing. Okay, missing values. It's no longer a part of the apple.close.log2. Okay, we could have just remove the open, high, low, volume, Apple adjusted. Okay, so that there would be only close that log one and close that log two. Okay, I could have done that, but I decided just not to do that. But you can do that, class. You can just create this object stock data, and it will only cover date and the closing. Okay, date and the closing only, and then you create stock data one, and then you include Apple that close log one, Apple that close log two, so that there will be fewer columns. Because anyway, we're not going to use the others. Okay, but I decided not to do that. You can do that as an exercise. All right. So this was manually done, class. We can do this, class, using dplyr. Dplyr is a package, class. This is a lot easier. Okay. So let's load first tidyverse. I'm sorry. And let's create now a new data set, stock data 2. So what's stock data 2? It's your stock data. And then if you recall, class, this is our pipe operator. Okay, di ba? Control Shift M, or in Mac, it's Command Shift M, if I'm not mistaken. And this means and then. The original symbol for that is percentage greater than percentage. We said that it's called the pipe operator, and the English translation of that is and then. So this means you start with stock data, okay, and then you use the mutate function of dplyr. I just inserted here dplyr so that you know where this function is coming from. And mutate, class, is a function where you include, where you insert, or you create a column or a variable. Okay, so mutate, class. And this is a lot easier than this one. Because imagine if you have log 5 here, if you're manually creating it, then you have NA, 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 etc. For this one, you just use N is equal to 1, N is equal to 2, etc. Okay, so let's take a look at the syntax, class. Once again, we create another object, stock data 2. We don't want to overwrite stock data, and we want to compare this with stock data 1. And then mutate, class. Okay, you know that it's okay not to write dplyr, but if you're if you're new in using mutate, I suggest that you also include, so that you know where it's coming from. And then the variable that we're creating, the column that we're creating, is the same thing, apple.close.log. And then we use the function log. Okay, log will get the uh, period log depending on what your n is. Okay, so we're using apple.close. Okay, apple.close. Remember, we can do this because we already identified where it's coming from. Okay, otherwise, class, we should use stock data then dollar then apple.close. But R understands that apple.close is coming from the stock data. Okay, recall, class, that there's no apple.close here, but we have stock data. And then we already referred to this. We're saying start with stock data and then mutate, create this variable apple.close.log1. What will this contain? The log of apple.close. N is equal to 1, which means log 1. Then N is equal to 2, it means log 2. And then you view it, class. Kindly check. I'll give you a few seconds. So kindly run this and tell me if the object generated data 2 is exactly as expected. It's also your stock data, and then you have now apple.close.log1 and apple.close.log2, which have two NAs for log2 and one NA for log1. Okay, I'll wait for your. Okay, good. Wow, very fast, no? Okay, good. Same result as earlier. Yeah, you're correct. Thank you. Thank you. Okay, so let's wait for the others. Good. Same then. Okay, so you have two ways, class. Two ways to do it. Tidyverse. Okay, we'll not use the other one. There are other ways to do it. Tidyverse is more than enough. Actually, pwede rin naman si ano, no, pwede rin si Zoo, no? Zoo has also lag. Pero yung n niya, k is equal to 1, k is equal to 2. So here I created stock data 3. But anyway, I'll leave that to you class as an exercise, no? To also create using the zoo, but you have to load first zoo. Okay, and there's another one class here. What I did here was to create a matrix because I'm creating this all together at the same time, Okay, so the advantage of this is you just need one. I don't need to create here I'm creating log 1, log 2, etc. Okay. All right. So let's now go to the more meaty, more important thing. What's we have already created the stock data one, so that's enough. Okay. We have already log 1 and log 2. Now we're going to make use of other indicators. You said that you discussed RSI, you discussed MACD, you discussed MA maybe, SMA, ME, EMA, etc. We're going to make use of several metrics, and then we're going to use them as predictors of the stock returns, the log returns. Okay, so let's first take a look at TTR. You don't need to install TTR actually because when you loaded quant mode, TTR is also preloaded with quant mode. So kindly check TTR here under packages, then TTR. Kindly confirm if it's already loaded class. I'm expecting you to say yes. Okay, thank you, Janine. Good. So loaded na siya class because when you load quant mode, TTR will also be loaded. So let's open this and see what is this package all about. Okay. So let's first start with the description of this file. Description. Okay. Okay, good. Thank you. Okay. Description of this file class. What's a description? Let's check. R has a pretty good uh, help what's this? Help function. Okay. So this is technical trading rules. Version niya, latest version 0.24.4. And when you use TTR, it also makes use of XTS, Zoo, curl, and this also enhances quant mode. So it's a collection of over 50 technical indicators for creating technical trading rules. Okay, so quite a lot. And the creator is Joshua Ulrich, another contributor. He's the creator and the author also. And another contributor is Ethan Smith. Okay, date of publication. This was 11/28. Uh, I think this is the update, no? Because I've been using TTR even before this. So I think this is the latest update, I think. Okay. All right, let's go back to our TTR. And then you have here several, so go back here. You have here several functions, class. Okay. ADX, okay. You also have Bollinger Bands here. Okay, average true range. There are a lot of uh, uh, indicators that you can use. Okay, the more common ones are itong EMA, moving average. This is your exponential moving average. Also your, what else? MA, moving average, MACD, moving average, convergence, divergence. Your RSI also is very popular, RSI. Rate of change also. Relative strength index. Okay. And then there are others. SMA. Okay, we'll be using some of them. We're not going to use all of them because that will take years. Okay, 2 years, maybe 1 year to discuss everything. Okay, so we're now going to make use of okay, TTR. Okay, so let me start with this one. Okay, the first one that we're going to use is one of the most simple one, moving average class. Okay, so if you take a look at this code, okay, so let's start with this one. So I'm using, yes, Kyle? Kyle, my question? Kyle? Kyle, choppy yung voice mo.
So, hindi po nag-run yung
Oh, sige.
ah,
Okay, yung ano, yung
zoo po.
which one?
Yung zoo po.
Yung zoo, oo, wag na muna yon ha. Wag na
Sige
muna.
po.
I'll discuss that ano na lang. Kasi habulin muna natin yung ano, no? Thank you, Kyle, for,
Sige.
ang bilis ha. Nakuha mo na kaagad yung zoo. I'll explain something about that, no? Kailangan ko lang, ang importante naka-generate na natin yung stock data 1. Okay, whether it's by manual or yung mutate function ni dplyr, that's enough, no? I just inserted there yung zoo. Okay, and Kyle was able to find out na may mali doon, ano? Okay, I'll explain kung bakit ganon yung zoo. Tapos yung isa pa yung embed function. Okay, mga ano na lang, mga let's call that dessert, no? So let's now focus first on the main meal. Is that okay, Kyle? Kyle, okay lang ba 'yon? Okay, I guess okay lang siya, no? Unless you have a question? Wala?
Sir, wala po, sir.
Okay, sige. All right, so let's now go here first. Let's go to moving average class. Okay, so what's moving average? So take a look first at this code, okay? So stock underscore data 1, remember we have created this, and then we're inserting again, we're creating a variable. It means that we're creating another column, let's call it MA20. So this is moving average 20. So it's a 20-day moving average. So we're going to use the TTR package, and the function is SMA, simple moving average. So what data are we using? We're using the Apple close data, apple.close data that's coming from the stock data 1. Okay. And then you define n is equal to 20. So let's first run this class, this one, and then tell me what happens. Okay. So that one first, yung 20. So if we take a look at stock data 1, okay, here. I now have MA MA20 class here. MA20. And the first value here is 27.66. And if you count this class, how many NAs? 1, 2, there are actually 19 MAs, and the 20th is 27.66. So let me just quickly explain what's happening here. How was SMA 20 or MA20 in our case here? How was that computed? So that's very easy. That's just average class. Okay, so let's do this first. Let's create a vector na lang class, AAPL, let's call it APL20 na lang. No? I'll just use AAPL20, alt minus, and then I'll get it from our object, okay, stock underscore data 1, and then dollar. We'll get the closing price. Apple close, okay, and then we will get rows 1 up to 20. Okay, so we don't need to identify the columns because this one will, okay, ayan, identify na rin natin columns, row 1 to 20, and then what column is this? 1, 2, 3, 4, 5, fifth column. Okay, so we're getting the first 20 observations of the fifth column. So that's actually Apple close, right? Okay, so we're creating this object Apple 20. Control Enter. Oops, sorry, what happened? In stock 20. Okay. So, okay, mali na to, no? Sorry. Yeah, I realized my mistake. So, wala nang 5 class kasi, okay, because when we mention that's only Apple close, isang column na lang yon, no? Kasi sabi natin, stock data 1, Apple close, ito na lang. So, I made the mistake of including 5. Isa na lang yan, class, di ba? If we read this, Apple close, ito na lang yon, no? It's only this one. And then I made the mistake of comma 5. Okay, so this one will now be Apple 20. Okay. So what's Apple 20 class? I'm sorry, here. What's Apple 20 here? It's a numerical vector. Okay, so it got the 20 observations of Apple close. Kasi 1 to 20, di ba? So, tinan nyo class, no? Apple 20, yan, 27.3, 26.6, okay? Naka-round off lang. So, let's get the average class, mean. Mean of Apple, aapl underscore 20. What is the average class of Apple 20? Control Enter. 27.66. Let's take a look at our MA20 class here. 27.66. Okay. All right. Let me pause for a while, class, and wait for you to see for yourself if indeed the average of the first 20 observations of Apple close is indeed 27.66. Okay. Paki-chat na lang, class, please. If you got the same answer. Okay. Good. Good. Great. So we were able to validate, class, that indeed, when you say SM8 n is equal to 20, you're actually getting the average of the first 20 observations. And then on the 20th class, this one is the 20th, you replace the value, okay, because this is your Apple close, right? Ito. It's 29.29. You replace it with the average. Okay. Same thing with this one, class. So this one is the average. It's a rolling average, class. Rolling average, which means it will now start with row number 2 up to row number 21. So maintaining the 20 previous values. So that's what we mean by SMA 20, moving average 20. You always get 20 observations, okay, and replace the last value with the average. Okay, so I hope that's clear, class. That's your SMA moving average 20. So as a practice, as an exercise, let's just take a look at this one. I just added this. Okay, this one, class. Here. Okay. MA5 class. SMA again, data 1, n is equal to 5. So this will be moving average 5. So it will get the average of the first 5 observations, every 5 observations, class. So it will keep on moving, but always getting the average of 5 observations. So if you run this, class, and then check your stock 1 data, your stock 1 data will now have, okay, another column, MA5. And true enough, class, as I said, it will replace the 5th value here, class, with the average of the first 5 observations of Apple close here. Can check that, class. Can check that. Okay, so that's simply your moving average. Okay, let's go to the next one. Okay. All right, this one, class, I did not discuss this with the other class. During the break, I decided to include this one. Okay, so anyway, I'll just Control C. In the interest of time, I'm going to share this in the chat box. Okay. So this is different class from the moving average, from the simple moving average. You have EMA, which is exponential moving average. If you recall, class, for the moving average, you just get equal weights for each of the observation. Okay, which means that you add the observations and then divide it by the number of observations. That's actually equal weight, class. So for example, yung SMA5 natin, MA5 class. This one, okay, it's dividing everything by 5 here, which is equivalent to multiplying each of them by 20%. Because 1 divided by 5, that's 20%, right? So this one times 20%, this one times 20%, this one times 20%, this one times 20%, this one times 20%. Okay? So that's your average, equally weighted class. For exponential moving average, it's biased towards the more recent values. Okay? It's biased towards the more recent values. That's why you have here EMA, exponential moving average. So for example, n is equal to 12. Okay, it will now have the first 12 observations. It will get the average, but it will not be equally weighted. So it uses a particular formula. We'll not discuss the formula itself. Okay, so that the more current ones, okay, the values, for example, yesterday, and the value the other day, the other day, 2 days ago or 3 days ago, as compared to the value 20 days ago. And that's quite logical because, okay, most probably the value, the most current data, the most, uh, the closest lag will have more impact or more bearing on the value today as compared to the value 20 days ago or 100 days ago. So most likely the value yesterday, let's say November 3, will have more impact on the value on November 4 as compared to the value January 1, 2025, right? Okay, so that's a logical thing to assume. So when we're doing EMA, it's more biased to the more recent values. So the computation will be different as compared to a simple moving average. Okay, same thing here. So here we're using two values, EMA 12 and EMA 50. Okay, so let's run this class, and it will be again inserted to our stock data, EMA 12 and EMA 50. So let's run this. And if we check stock data 1 class, we now have EMA 12, okay, and EMA 50. Okay, as I said, the formula for computing the exponential moving average is different from the SMA, the simple moving average. And EMA 50, of course, will get the average of the first 50 observations here. Okay. All right, let me pause for a while and ask you, class, if you're able to follow. Could you kindly chat, please? Okay, good. All right, so we're collecting some technical indicators, class, because we're going to use these technical indicators in regression. We're going to model the log returns of the price of Apple, making use of the returns of our technical indicators. Okay, so let's continue, class. All right, let's do our RSI now, relative strength index. So the function is easy, class. It's RSI. Okay. So once again, we use stock data 1, $RSI 14. Usually it's a 14-day relative strength index. That's the benchmark. Okay. And then same thing, use TTR's RSI, and then N is equal to 14. Okay, I'll leave you class to research on how RSI is computed. It's a very simple formula, 100 plus 100 over 1 plus RS. Okay, so I'll just leave you class in the interest of time to research on how RSI is computed. I'll run this. It's just basic math class, no? And I want you to at least take a look on the use of RSI. So if we go here, you have here RSI 14. No? So take a look here. The difference here is that if you check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It starts on the 15th. So it takes the whole 14 previous data, use it for the computation, and then puts the computation on the 15th. Bali, n plus 1, 14 plus 1 on the 15th. Okay, so once again, I said, you notice that it's different class. From the MAs, which are just averages, RSI is quite different in terms of computation, even for EMA, okay, whether it's EMA 12, okay, or EMA 50, well, it really depends on how the prices have been going on. Okay, here the values are already 30 and the average is 29.30, so makes sense. Right? But here it's 57. So you're actually measuring a different thing. It's not the average. Okay. I leave you class to at least find out what that is. The formula is very easy, class. It's a very simple arithmetical formula. Okay, so let's keep class MACD. Okay. I did not discuss this. So anyway, let's discuss this. For MACD class, moving average, convergence, divergence, you have to identify the fast and the slow class, and then the significance, okay, and then you have to include percent is equal to false. Okay, we'll explain this as we go along, class. I'll be requiring you to at least do some readings on the merits or on the uses of the different indicators. We will not have time to really go into that deeply, class. I hope your experience with Fin in PM, no? Fin in PM. Are you taking it now, class, or was it last term? Are you taking that subject now or last term? Okay, so last term. Okay, good. All right. Okay, so using our class, we can generate the MACD of Apple. Okay, here we're not yet class putting it in Apple. Okay, in stock data one, we're just creating an object first, MACD output, and it will generate MACD and signal class. Okay, so let's run this. Okay, let's run this and take a look at MACD output class. Okay. So you have here two columns, MACD and signal. MACD starts with 26, and then signal starts with 34, 9. No? Significance of 9. Okay. Once again, I'd like you to try to see, class, what's generated with MACD. Okay, this is not a subject really on investing or using technical trading. We're using this class for regression. Okay, so I would like you to, I hope you spend some time, class, taking a look at if you haven't taken the subject, then maybe this is a good time for you to also try to research on what these metrics are. Okay, so what we're going to do, class, is we're going to make use of the output here in the MACD output and put it in our stock data. So we're generating this, class, stock data one, let's call it MACD, and it's coming from the MACD output here. Remember, class, I showed you that MACD output has the column MACD and the column signal. Okay, or you can have placed here 1 and here 2. That's another way to put it. So the elements, the output from this object will be transferred now to stack data 1. Okay. And there's a reason for that, class. We could have directly use here, okay, stack data 1. Okay. However, class, kasi dalawang outputs ang i-generate, no? Okay. So hindi pa we could not have I take back my word, class. That's the reason why I first created this object. Why did I create this object? Because MACD output will have two outputs, the MACD, class, and the signal, this one. So I could not have used stock signal 1, okay, stock signal 1, because I could not have used $2 here. Okay, so now okay, let me hurry up a bit so that we have the same. Okay, so I now insert an object called a variable called MACD, and it's from the MACD output. Okay, so this is the first column. I can put here column 1, and this one I create MACD signal and call it signal. Okay. So in the interest of time, class, I'll share this with you. Okay, this two. And then we'll go to the Control C, chat, Control V. Okay, we have a few more minutes, just 6 or 7, and we have still some codes to cover. All right, so let's run this, class. So what will happen here? Now stock data 1 will once again be populated with this column MACD and MACD signal. And also we're going to create another one, class, another column, another variable. We'll call it MACD underscore histogram. And it's the difference between MACD and MACD signal. So it will create the histogram, class. Okay, let's run everything here and check our stock data 1. And you can see now that there will be 3 columns generated. Okay, so the 3 columns now are, okay, you have now your MACD, class, here, which we said starts at 26, right? Here, class. And then we have our MACD signal, and then our MACD histogram, which is the difference between the two. Okay, 1.37 minus 1.25 is 0.1144. Okay, MACD minus MACD signal will be your MACD histogram. Okay, so I'll postpone, class. I'll not postpone, but I'll ask you to please do some reading about this MACD to moving average, convergence, divergence. What's the meaning of this? What's the signal? And what's the difference between MACD and MACD signal, which is the histogram? Okay, so let's now go to, I have only a few more minutes. I'll not discuss that, class. I created a plot for this one. The plot, class, is what you saw a while ago. I don't know if you saw the plot, class, which I think I deleted it here. Okay, so let's now go here, class, because we can't use yet stock data 1, class, because there are many NAs. So what we're going to do is we're going to delete, class, the NAs. That's very easy. So stock data 1, NA.omit stock data 1. Okay, I'll leave you to write that, class, because that's very easy to write. So you can now view stock data 1. I'll give you a few seconds, class, to run this code and see Okay, see what happened to your stock data 1. I should have used stock data 11, but anyway, so that we can preserve stock data class. I should have used stock data 11. If you want, class, you can use stock data 11 so that stock data 1 is preserved. And once you're done, kindly please chat. Yeah, thank you so much. Very good, very fast feedback. I hope the others are able to follow. Okay. All right. So let me also run this. As I was saying, you could have used another name, stock data 11, if you want to preserve stock data 1. Okay. Anyway, I'll just use stock data 1. So which means it will overwrite the existing stock data 1 with many NAs. So here, and then let me view it. Okay, now my stock data 1 consists of data. Okay, with no NAs, no more NAs, diba? Okay, there you go. So we only have 2466 observations. Okay, all right. And then if we sum up, class, sum is that NA of stock data 1. This will lead to 0. Okay, then it's almost time, class. I think I'll have to share this with you. Okay, Control C. I'll just share this in the chat box. Control V. Let me reduce it. Okay, so sensitive. Control X. Okay, Control D. Okay, so copy that, class. This will be very quick. Okay, so we said that there's no more missing data, NA data. Now, when we split our data into 2, as I said a while ago, class, we do not randomly split the data, because otherwise, if you're going to just pick up some values from the data set, class, from our stock data 1, randomly pick up values and then put it in training and testing, that will destroy the structure of your data, the time series structure. So how do we now split this into training and testing? So let's suppose 80% will go to training and 20% will go to testing. So let's first create this object, train size, okay, that will determine how many observations will go to train our train data. So we're going to use the floor class, floor function. Okay, floor, and then we're going to compute, multiply 80% of the number of rows of our stock data. Our stock data has 2466 observations. Okay, and 80% of that will be Control Enter. So you can now see that our train size is 1972, and that's 80% of 2466, which is our our stock data 1. It's 1972, class. So what are we going to do, class? How are we going to split our data? So first, our trained data will be from, we'll get it from the stock data 1, of course. It will be from the first row up to row, what's train size, class? 1972. Okay, so imagine this, class. So from row 1 here, row 1 up to row 1972. So you don't choose the index here because it's starting with 50, class. So 1, 2, 3, 4, etc. up to 1972. And what will happen is that it will preserve, class. It's already time, so you may just leave, class. For those of you I'll just continue recording, class. This will take around 2 minutes only. Okay. So from 1 up to 1972. And then for the test data, it's stock data 1 again. Train size is 1972 plus 1, class. So it will now start with data 1973 until the number of rows of stock data, which is class 2466, comma, include all the columns, class. This is the row, and then the column. Okay, this is the row 1 up to train size, and then this is the column. Not putting anything in the column means include everything. All right, so let's run this. This whole code chunk. Let's run this whole code chunk. And let's see, class, how many observations do we have for training data set? Okay, we know that it will be 1972 here. Of course, the remaining will be your testing data set. And then here, let's check, class. Okay, we can view. I'll leave you, class, to view the train data and the test data. Let's just print, class, the first observations, first 5 observations for the train data, last 5 observations, the tail, class, for the train data, and also same for the test data. So let's run this. Okay, so you can see here, class, for the train data set, the first 5 dates, okay, you can see it's chronological, and the last 5 dates, it's 2023-01-11. For the testing data, this will end 23-01-11. This will start 23-01-12. Okay, and then this will end, class, 2024-12-30. That will be the last day of the stock data 1. Okay, so with that, class, we end our discussion. We were able to split our data. We'll continue with this, class, with now we're going to generate now the okay, here, class, we're now going to go to the machine learning, class, aspect of regression. We're going to create now first our decision tree model, etc. We're going to use the variables. Okay, so let's I'll stop recording.